Hi friends, welcome to a Co-Engineer YouTube channel. Today we discuss about probability theory and stochastic process. In the subject we have to discuss about probability theory, the unit 1. In this topic we have to discuss about sample space. Now we discuss sample space. When a physical experiment is performed, the set of all possible outcomes of the experiment is called sample space. It is denoted by S. In fact, the sample space is the universal set of the given experiment. For each trial of an experiment there is an outcome. For example, the experiment tossing an unbiased coin has two outcomes, heads H and tails. Head means H or tail means T. So the sample space H comma T in another experiment throwing a single die has six outcomes. The sample space is 1, the forward bracket is open, 1 comma 2 comma 3 comma 4 comma 5 comma 6. The forward bracket is closed. What is discrete sample space? Here this is in sample space. What is sample space? When a physical experiment is performed, a set of all possible outcomes of the experiment is called as sample space. Whenever the set of all possible, whenever an experiment is given, the experiment all outcomes are possible. That experiment is called as sample space. Now, discrete sample space is nothing but the sample space is said to be a discrete and finite offset in the sample space have finite number of elements. For example, the set forward bracket is open 1 comma 2 comma 3 comma 4 comma 5. The forward bracket is closed is an finite set. For this, if the set is in sample space have infinite number of elements, then the sample space is discrete and infinite. The set of sample space have infinite number of elements, then the sample space is discrete and infinite. Now, for example, the set of discrete sample space 1 comma 2 comma 3 and so on infinite is called infinite set. Now, continuous sample space is nothing but the sample space containing infinite number of elements which continuous value within a given range, then it is called a continuous sample space. For example, the set of numbers from 0 to 10, the elements are infinite and continuous. First, now events. Now, an event is defined as a set of possible outcomes of an experiment if it is a subset of sample space. For example, in the experiment, draw a spade card for a deck of 52 cards. There are 13 possible outcomes. Here, draw a spade card is an event. It is a set consisting of 13 spade cards. Similarly, tossing a coin is an event that has two possible outcomes, heads or tails. In a sample space has a set of n elements. The number of events subsets are 2 power n. Drawing cards from a deck of 52 cards has 2 power 52 events. Here what is discrete and continuous events? The discrete and continuous events is nothing but a discrete sample space has discrete event. When a coin is tossed, the event head is discrete and finite events takes place taken from continuous sample space or continuous selecting a number of randomly in a given range is a continuous event. Here there are infinite number of events. For example, any number in the range s is equal to here the event of s is equal to flower bracket is open 1 less than or equal to s less than or equal to 10 is a continuous event. Now what is certain and impossible events? See, certain and impossible events is nothing but an event is certain if it always appears as an outcome. An event which never occurs in an impossible event. A null set is an event which no element, it is an impossible event. Now, mutually exclusive event. What is mutually exclusive event? If any two events in an experiment have two common outcomes, then events are said to be mutually exclusive event. For example, the event draw a king card and draw a queen card from a deck of cards are mutually exclusive events because both events cannot occur at the same time. What is equally likely events? In a given experiment, if one of the event is a sample space does not depend on any another event, then two events are called equally likely events. For example, by throwing an unbiased dice, all faces shown are equal likely events. Also, while tossing an unbiased coin, getting heads and tails are equally likely events. Now the exhaustive events. Now all possible events in a sample space are called exhaustive events. For example, consider an experiment of throwing a die. The exhaustive events are 6. Then two dice are thrown. Exact two events are 36. Similarly, drawing a card from a deck of 52 cards, the exact two events are 52. What is the favorable events? Favorable events is nothing but if you even a favor, which are favorable for your experiment, how to throw out from the deck of the cards. In a given experiment, a number of outcomes which are favorable to get the required events are called favorable events. For example, while throwing a die, if the required events is getting an odd number, then the favorable events are 1, 3, 5. The number of favorable events are 3. Here, similarly, from the deck of 52 cards, the required events is getting a king card. The number of favorable events are 4. What about the equality of events? The equality of events is nothing but if n given sample space S, two events are called equally if both events have the same element. If A and B are equal events, A is equal to B or A intersection of B or A union of B. This is the relation of when the two events are equal. What are the events with set relations? Here an event x does not occur. This is like this. When event x does not occur, nothing but the complement is not occur. Both events x and y are occur. X intersection of y. The x value is in the form of y. Both are intersection of the form. Both are in x and y occurs. The symbol is x and y are intersection. At least one of the event x or y occurs, or either yx or y occurs, the x union of y. If one and only of the two events, the one or function of the event is occur, this function is like this x union of y. Neither x nor y. Here x complement intersection of y complement. Here either the x complement or y complement can be formed. Event x occurs when y does not occur. Even x occur, y does not occur. Here x minus of y or x complement, x intersection of y complement. Here even x is occur, y does not occur means y is complement, its value is 0. Exactly one of the event A and B are occur. Here A and B are occur, that's why A intersection of B complement union of A intersect A bar A complement intersection B. This is exactly one of the event A and B are occur. This is about sample spaces and events of a probability theory. Thank you friends, thank you very much.